So next we have the second derivative test. Already done with the first derivative test. So sabi dito, suppose that x is equal to constant is a critical point of the first function, the constant, such that if the first function of constant is equal to 0 and the second derivative of x is continuous in a region around x is equal to constant. Then, if the second derivative of constant is less than 0, then x is a relative maximum. But if the second derivative of constant is greater than 0, then x is constant is a relative minimum. But if the second derivative of constant is equal to 0, then x is equal to constant can be a relative maximum or relative minimum or neither. So this is now the first graph. The first is the graph of the function of x is equal to x to the fourth. This graph has a relative minimum at x is equal to 0. So if we're going to look on our first graph, this is the graph of a fourth degree equation. Kasi yung second degree po natin, that is the parabola. Maganda yung shape po niya, no? Okay? So dito, meron tayong fourth degree equation. And this is now the graph of a fourth degree equation opening upward. Sabi niya, this graph has a relative minimum at x is equal to 0. Ito po siya. So dito wala tayong absolute maximum, no? Kasi walang endpoint ito. Okay? Although we are going to emphasize yung relative minimum dito. Okay? Next. Next is the graph of the function of x is equal to negative x to the fourth. Kanina, positive opening upward. Ngayon, negative siya, opening downward. It has a relative maximum at x is equal to 0. Kanina, meron tayong relative minimum dito. Kasi nasa baba po siya. Ngayon, dahil nasa taas po siya, yung vertex po niya, then we can say this is our relative maximum. Ito po. Okay? Next. Finally, there's a graph of the function of x is equal to x cubed. And this graph had neither a relative minimum or a relative maximum at x is equal to 0. So this is the difference between the third third function or the third degree equation and the fourth degree equation. Yung third degree equation, ito yung form ng graph po niya. Sabi dito, had a neither relative minimum or relative maximum. Pag dito tayo nagsimula, this will serve as our relative minimum. Pero pag dito tayo nagsimula, this will serve as our relative maximum at x is equal to 0. Example here, use the second derivative test to classify the critical points of the function. X equal to 3x to the fifth minus 5x cubed plus 3. So by this time, we are going to get the second derivative. So how are we going to get the second derivative? So we're going to get the derivative of the first derivative. So una, y muna siya. Pangalawa, y prime. Tapos kukunin natin yung derivative nyo ulit. That will be your y double prime. So tulad po dito, this is our x. First derivative, x prime. Second derivative, it's double prime. Note that all we are doing here is verifying the results from the first example. So by this time, we have now your second derivative. Paano po siya nakuha? Paano naging 60x cubed minus 30x ang ating second derivative? So ganito po siya. If h of x equals 3x to the fifth minus 5x cubed, 5x cubed plus 3, if we're going to get the first derivative using the power rule, okay, 5 by 3 is 15x raised to 4. 15x to the 4th, ito naman, minus 3 by 5 is 15x squared. Derivative ng 3 is 0. So therefore, the first derivative will be 15 x to the fourth minus 15x squared. Yung 15x to the fourth, 4 times 15, magiging 6 na po siya. Then, x to the fourth minus 1, magiging x cubed. Tapos yung 15x squared, 2 by 15, so we have 30x. X raised to 2 minus 1 is 1 na po siya. So therefore, this is now your second derivative. Next, the three critical points. Paano nakuha yung minus 1, 0, and plus 1? Dito po, no? So if we're going to factor this one, you're going to have 30, okay, multiplied by x squared minus, or 30x. That is their common factor, no? 30x multiplied by x squared minus 1. Okay, so that is their factor, no? 30x quantity x squared minus 1. So yung 30x by x, x cubed. 30x by 1 is 30x. So what's left here will be x squared minus 1. From our algebra, the square of a binomial, if we're going to factor a squared minus b squared, we're going to have a plus b, a minus b. So with that, the factors are 30x, we have x plus 1, x minus 1. So if x plus 1 is equal to 0, our x will be negative 1. If x minus 1 is equal to 0, our x will be positive 1. If 30x is equal to 0, our x is equal to 0. So therefore, these are our three critical points. Of this function, sabi po niya na this function are all critical points where the first derivative is 0. So we know that we at least have a chance that a second derivative test will work. So the value of the second derivative for each of these are, if x is equal to negative 1, okay, from our first derivative, the answer is negative 30. Or if x double prime is equal to negative 1, the answer is negative 30. If x is equal to 0 from h double prime, the answer is also 0. If h double prime is equal to 1, the value of our x, the answer is 30. Okay? Sabihin nun, this one is your x. Yung mga critical points po natin, this is your x, 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 and this is the value of our y. Negative 30, 0, and positive 30. So the second derivative at x negative 1 is negative. So by second derivative test, this critical point, this is a relative maximum, as we saw in the first example. The second derivative at x is equal to 1 is positive. And so we have a relative minimum. Here, by the second derivative test, as we also saw in the first example. In the case of x is equal to 0, the second derivative is 0, and so we can't use the second derivative test to classify these critical points. Note, however, that we do know from the first derivative test we used in the first example that in this case, the critical points is not a relative extrema. Okay? So, thank you. That ends our discussion for today, which is all about the applications of derivatives 2. Thank you.